Okay, so as in the last video, we have discussed about the most important topic of this chapter, stoichiometry, and that was, of course, related to molecular formula and empirical formula. So, what was molecular formula? Molecular formula was basically a formula in which we were get to know about the actual number of atoms which were present in any molecule or compound, right? And we have looked into the examples as well. We have gone through two examples, the glucose and the ethene. The molecular formula of glucose was 6C6H12O6, which was basically letting us know about the actual number of carbon atom, hydrogen atom and oxygen atom which were present in the glucose molecule. In the second, we have discussed about the ethane, right? In ethane, we got to know that how many number of atoms are present of carbon in the ethane and how many number of atoms of hydrogen are present in the ethene molecule, right? Secondly, we discuss about the empirical formula. Empirical formula was nothing but it gives us the simplest ratio of the atoms which are present in the molecule or in the compound, right? For example, we know that the molecular formula of glucose is C6H12O6. When we took the ratio of it, we took ratio of it and we got 1:2:1. By that we got to know that the empirical formula of glucose is CH2O, right? Then we took the empirical formula of ethane as well, and the actual formula or the molecular formula of ethane was C2H6. When we took the ratio of it, we got to know it gives us the 1:3, means there is only one carbon atom and 3 hydrogen atoms present in the empirical formula of ethene, right? In today's video, we are going to see how we can, if we have empirical formula given in the question, how we can convert that to the molecular formula, right? So that is basically very easy, right? Initially we need to understand. So here I am writing molecular formula. I'll be letting you guys know about the formula as well, how you can go through that formula, right? Molecular formula, here empirical formula, right, which gives us the simplest ratio of the atoms present in any molecule or compound. Empirical formula, right? Molecular formula and empirical formula. Now let's take an example of ethene first, right? Ethene. We know that what is the molecular formula of ethene is C2H6, right? And what is the molecular empirical formula of ethene? It is basically CH3, right? Means I need to multiply the empirical formula with any number, with a particular number, to get the molecular formula, right? If I do multiply this entire value with 2, I can get, right? Means here I have 1, so this 1 would be multiplied by 2, 1 2s are 2 h, this 3 multiplied by 2, so 3 2s are 6. Means I can get the molecular formula by multiplying a particular number with the empirical formula, which means I need to multiply a particular number which I don't know yet, right? I need to multiply n with the empirical formula to get the molecular formula, right? Here we have just understood that. Now let's take an example of glucose. Let's take an example of glucose, right? And the formula of glucose is C6H12O6, right? And the empirical formula of glucose is CH2O. I need to multiply a particular number with this empirical formula to get the actual number or the actual, the molecular formula, right? Now I need to find this n. How I'm going to find this n? Means what particular number do I need to multiply with the empirical formula so that I can have a molecular formula of it. So let us write here the molecular weight first, right? I'll let you know what is molecular weight, what is empirical weight. So molecular weight, basically you will be finding the mass of this molecule, and that would be equal to the molecular weight, right? So we know that what is the mass of the carbon, it is 12, and there are basically 6 atoms of carbon, so multiply by 6, plus the mass of the hydrogen is 1 and there are 12 atoms of hydrogen, so multiply by 12, plus the mass of the oxygen is 16 and there are 6 atoms of oxygen, so multiply by 6, right? When we multiply this entire value, we'll gonna get 180 gram, right? So the molecular weight of glucose is what? It is 180 gram. Let's find the empirical weight. So the mass of the carbon is 12, and of course there is only one atom, so no need to multiply the 12 with 1. The molecular mass of hydrogen is 1 and there are 2 atoms of hydrogen, so multiply by 2, plus the mass of the oxygen is 16, right? So 12, this is basically plus 2 plus 16 gives us 30, right? Now I need to multiply this 30 is basically what? This is the empirical weight, right? So now I need to multiply a number. Basically I'm finding the number here. What number do I multiply the empirical formula with so that I can have a molecular formula? So multiply by n, right? Now I need to find this n, of course. So 30, let me write this equation here. 180 is equal to number and it is multiplying with 30, right? Molecular formula is equal to n into empirical weight, right? So 30 is multiplying here, it will go there, it will be divided. So n is equal to 180 by 30, right? So 0 0 cancel, 3 1s are 3, 3 6 are 18. Thus we get n as 6, right? Now let's multiply this empirical formula with 6. Let's check, will we get the molecular formula of the glucose or not? Basically the empirical formula is CH2O and the value which we have got is means the n is equal to 6. So here we have 1 multiplied by 6 is 6, right? 2 multiplied by 6 is 12 and 1 multiplied by 6 is 6, right? So C6H12O6, we have basically got the molecular formula. Here we have got another formula as well which we will gonna use for finding the n number, a particular number which we will gonna multiply the empirical formula with to find the molecular formula, right? So that n is equal to molecular weight upon empirical weight. Right? So this is the most important formula which you need to learn. Then you'll not gonna face any difficulty in finding the particular number which you're gonna multiply your empirical formula with, so that you can have a your molecular formula, right? So here you can see 180 was what? It was nothing but it was the molecular weight of glucose molecule, right? And empirical formula in this case was 30. 30 was the empirical weight and 180 was the molecular weight. So molecular weight upon empirical weight means 180 upon 30, it will gonna give you the particular number which you will gonna multiply your empirical formula with, so that you will be getting your molecular formula, right? So this was all for today. As we have discussed a very important topic today, we basically got to know that how we're gonna calculate the molecular formula if we have already empirical formula given in the question, right? We have done two not two, however one basic numerical. In the next video we will gonna go with theoretical yield, practical yield and experimental yield.